All right, let's talk renewables. Let's talk the good ones. So there are three main renewables we're going to talk about: wind, solar, and geothermal. And all three of these are actually readily available here in California, and they have actually been more and more utilized over time. And with our increasing renewable energy portfolio, they're going to continue to become more and more important. So let's chit chat about these really quickly. First, wind driven by if you've ever driven from 580 between Livermore and Tracy, you've gone up and over Altamont Pass. There's a big wind farm there. If you've ever driven over the Pacheco Pass, that's the pass that is between Gilroy and Los Banos. That's Highway 152. If you've ever driven over that before, there's a much smaller wind farm, but still a pretty good wind farm there. If you've ever driven down between Bakersfield and Barstow on your way to Viva Las Vegas, you've passed through the Tehachapi Mountains. There's a nice wind farm there. And then if you've ever driven to Palm Springs before, really the only way to get from here to Palm Springs is to take Interstate 10, which between Riverside and Palm Springs goes up and over the San Gorgino Pass, and there's a lot of wind farms there. So those are the four big wind resource areas here in California. And we have actually seen a nice little bump up in electricity generation from the 90s to now, and we've actually seen continued investment and continued growing of wind-powered plants here in California. And so the way that wind farms work, and so this map right here shows areas where there is potential for wind resources. And as you can see, there's a lot in the Sierra Nevadas, there's a lot in the coastal ranges. So there are a lot more resources that we can tap into. We just need to do that. So here's the Altamont Pass wind farm. Every time I drive by it, I always get really excited. I actually had a friend named Kevin who actually wrote a thesis on predicting winds in the Altamont Pass, so they could figure out like how to best plan for the amount of energy that they can produce in a given day. And the more you can prepare for that, the better you can harness the energy, better off you are. So here's how the process works. Wind hits the fan, the giant blades of the turbine. That causes the turbine to turn. Now, as the turbine turns, it actually feeds electricity into a grid. This is kind of familiar to when we were talking about nuclear and hydroelectric energy. Basically, the energy being transferred from the wind to the rotation of one of these turbines then feeds into the electric grid. And so that's really what happens here. So the turbine turns, that then turns a generator, which makes the electricity. The electricity is then fed into the grid. It's then transformed into a usable current, and then boom, it comes to us. So that's how wind energy works. Solar power, however, has been the big one here in California. In 2009, less than 1% of all of California's energy came from solar electricity. Now, it is closer to 19%. So we went from very, very, very little solar electricity to massive amounts of solar electricity. And here in California, we actually live in a really, really good place for solar electricity, unless you are right on the coast. And only during certain times of the year, much of California gets a lot of sunshine. We don't get a lot of rain, we get a lot of sunshine. So there's a lot of places where we can harness electricity from solar power. Our Central Valley in particular is a really good place for that. And so as a result, many wind farms, such as the Topaz wind farm behind me, my background, have been built in the last roughly 10 years to take advantage of all of the sunlight that we have here in California. There are two main forms of solar electricity, and we've primarily used what's called photovoltaic. And basically what that does is it uses the energy from solar radiation, from those photons of solar radiation, to then produce an electrical current. Thermal, on the other hand, uses sunlight to heat up a fluid that's embedded in the solar panels. That fluid then transfers into a tank, and then that tank is then used to produce the electricity. So photovoltaic is actually the more attractive one. And it's really the one I'm going to come today. So California, we have a lot of land. We have a lot of very sunny places. And so we've really been able to harness our electricity. And in fact, sorry, I kind of tripped on my tongue there for a second. Rainier part of California, that's actually the far northern part, pretty much north of the Bay Area, has the fewest number of solar farms. But the drier parts of California, so in the East Bay, and then down in San Luis Obispo County, where Topaz is located, and then in the Central Valley, and then down in the desert Southwest, those areas get a lot less rain, more sun, and what do you know? We get a lot of solar power there. So once again, here's the Topaz solar farm, the one that's right behind me. So if you want a better picture, you can look right behind me. The Topaz solar farm is the world's largest solar farm. It was commissioned in 2014, so it was launched in 2014. It started actually producing electricity in 2014. It's a large part of California's solar production. It's not the only part, but it's a large part. So there's a lot of steps here in how photovoltaic solar electricity works. But here's basically what happens. Sunlight leaves the sun, makes that 93 million mile journey to Earth, makes its way through our atmosphere, and gets absorbed by the silicon in the solar panel. What this actually does is when the silicon absorbs this, that makes the silicon really, really hot. And that also makes the silicon really, really energetic. This causes electrons to free up. These electrons break apart, and then they begin to dart away. And that's actually what creates an electric current. That electric current is then fed into an inverter, where it's then turned into a usable electric current. This turns it into a current that we use. That then is fed into a breaker box. And then eventually it's fed into either outlets if you actually have panels on your roof, or it's fed into the electrical grid. Believe it or not, one of the coolest things that's happening with solar technology now is that it's becoming a lot cheaper to make, and they're becoming a lot more convenient. And as a result, because of that, solar power is becoming a lot more accessible here in California and all around the country. And so there's a real big push to go solar right now. A real big push to go for solar right now. Here's one of the cool things. One of the cool things is that in some areas, whatever electricity you don't use, if you end up producing more electricity than you use, the unused electricity actually goes into the electrical grid and can then be used by somebody else. And depending on the payment plan you have for your solar panels, depending on the energy company that you live with and so on, you may actually even get paid for unused solar energy that is then provided into the electrical grid. So instead of getting a bill, you may actually get a check each month. Kind of a cool idea. Now, I don't want to say for sure that that's how PG&E works here in California. We tend to not pay people too well for stuff like that, but still kind of a cool fact. So that's how solar energy works. And then just a few other California renewable projects. So using more desert lands for wind and solar energy generation. It's important to note, though, that these lands aren't necessarily uninhabited, unclaimed land. Much of this land may actually be on Native American reservations. It may actually be owned by somebody else, by farmers. It may actually be owned by a wildlife refuge. There may be ecosystems that could be affected. And so collaboration has to be done with stakeholders in using those lands. And then geothermal. So there are some parts of California, specifically the northern part, as well as parts of the Eastern Sierra, that actually have geothermal activity in them. Lassen Peak and Mount Shasta in the northern part of California are actually both volcanic mountains. So they both sit on top of a magma chamber. And then in the Long Valley area, there's actually a magma chamber called the Long Valley Caldera. And we can actually extract heat from those magma chambers to then actually be used for space heating for when it gets really cold. So instead of having to like use oil or natural gas, we can actually feed heat in from those magma chambers. Now, obviously, with all the bad stuff that might be in there filtered out. And for power production, we can use that heat to then heat up water, to boil it, to then cause turbines to turn. And that's actually one way that we can actually use geothermal programs. And then finally, there are also laws that have come out, and this is somewhat controversial in my opinion, that require new housing buildings. So this is housing that new permits are being written for. So anything that was before 2020 was grandfathered in and didn't have to do this. But new housing construction, anything from here on out, has to include solar panels on its roofs. Now, I know what you're thinking. Wow, aren't California houses already expensive? Well, the cost of adding solar panels to a house raises the price a few $1,000s. It doesn't raise it 50,000, 70,000, 90,000, 200. It doesn't double the price of your house. Now that being said, it is yet another thing you have to pay for, which is what makes it somewhat controversial. However, there are two big benefits to this. If you have solar electricity, first off, that reduces your energy costs. So over time, whatever you paid for getting those solar panels on, you're going to get back. The other big benefit is that you are not necessarily at the beck and call of a company like PG&E when they turn off people's power due to fires or due to other things like that. They can't just shut off your power. Why? Because you have your own electricity being generated. You can actually rely on that as long as you're getting solar energy, you can actually rely on that. So those are some benefits of renewable energy, and especially here in California. Now, for the next part of this module, we're going to talk about what we actually do with the energy we create. So that's what's coming up next. What do we actually do with all of this energy?